In today's class, we're going to see how to solve this question. We want to find the height of this man. Standing between two walls, the wall on our left is 4 meters tall, the wall on our right is 6 meters tall. How do we go about solving a question like this? First things first,
I would love that we take this entire image and render it in lines. Okay, let's just see the image in a different light. We're going to be using this for our calculations. Here is the 4-meter wall. Here is the 6-meter wall. The man is here. Let's call his height h. This is the distance between the two walls. Let's call it d. And now let's label the entire thing. So let's call this A, B, C, D, E, and F. Recall that D is just the distance between the 2 points, between these 2 points. So let's write that as D. Okay? Now let's call the distance between F here and G, between the man and the 6-meter wall, let's call it X, which would make the distance between A and F, D minus X. What we have here is a classic case of similar triangles. How do I know what are similar shapes? This is a question you might be asking. Similar shapes are two shapes that have the same properties, especially in terms of angles. They have the same angles, not necessarily the same size, but the sides are expanded by the same scale. So if I have, let's say, a rectangle 4 by 3, a similar shape to this rectangle will be an 8 by 6 rectangle. Okay, these are similar shapes. A 4 by 3 rectangle will also be a similar rectangle to that, but mostly we call those kind of shapes congruent. Okay, but that's not what we're here today. So this is a classic, as I said earlier, this is a classic case of similar triangles, similar shapes, and we have similar triangles here. What are the similar triangles we have here? We have two similar triangles. Triangle ABC is similar to triangle EFC. Okay, because they have common angles, they have the same angles. If this place is 90, this place is 90, they share the angle at C. That means this angle here and this angle here must be the same. Okay, so if they are similar, the law around similar shapes is that if they are similar, then we can say that h over 4 is equal to x all over d. Okay, which will then make x, if we make x the subject of the formula, x will be hd all over 4, and we can call that equation 1. Similarly, we find that triangle ACD, A, C, and D is also similar to triangle EFA. Okay, so triangle ACD is similar to EF and A. So that if we apply the same rule and say that the height here, this side, h all over 6 is equal to d minus x all over d, then we can say that d minus x is equal to hd all over 6. If we replace x here with all of this x, like we're solving simultaneously now, we will then have d minus hd all over 4 equals hd all over 6. 6, not d, sorry. hd all over 6. divide through by d. Seeing as d is not equal to 0, d cannot be equal to 0 because d is the distance between the two walls, right? D is the distance between the two walls. So we can divide through by d, so that d divided by d is 1. hd divided by d is h all over 4 is equal to h all over 6. We can say that 1 is equal to h all over 6 plus h all over 4. So that 1 is equal to, this is simple fraction, 2h all over 12 plus 3h all over 12, which gives us 1 equals 5h all over 12. And then we can say that 5h equals 12. If we divide through by 5, h will be equal to 2.4 meters. And that is the height of the man. That is the height of the man standing between both walls. Okay, I hope you learned something today. Stick around for other lessons. See ya. Bye.